Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazir Afiq bin Masrukin, and I'll be explaining about the additional theory in topic 4 regarding the principle of moment.
So this is my group and we are from group 9.
As most students already know, the effect of a force on rigid body depends on its point of application as well as its magnitude and direction. It is common knowledge that a small force can have a large turning effect or leverage.
Turning effect, or also known as moment, is the product of force which is multiplied with the perpendicular distance from the force line of action to the pivot. The principle of moment states that when in equilibrium, the total sum of the counterclockwise moment is equal to the total sum of the clockwise moment about the same pivot. Before we get to this picture, let's take a look at the formula first. Moment equals to force F times with perpendicular distance from the pivot, or we can call it as D. So according to the figure, we can see that 10 Newton is multiplied with 2 meter and resulting with 20 Newton meter. Meanwhile, 20 Newton is multiplied with 1 meter resulting with 20 Newton meter. Newton meter is the measurement for moment. Can it be applied with this picture? 600 Newton times with 2 meter in anti-clockwise moment, while 300 Newton times with 2 meter in clockwise moment.
So before we end the slide, for my part, there are several conditions for equilibrium. The number one is the resultant force must be zero. Second, resultant moment about the pivot is zero and the principle of moment must be applied. The typical sign convention for a moment in 2D is that counterclockwise is considered positive. We can determine the direction of rotation by imagining the body pinned at zero, and deciding which way the body will rotate will be mainly on the force, whether the force was going downwards or upwards. Thank you very much, and I will giving it to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aimadina bin Muhammad Fuad. I'm from Group 9 for the subject Engineering Mechanical Laboratory. So based on the observation that we got from the experiment is that first, the link joining the principal moment of apparatus are not functional due to the frictional wear. Second, poor skill or handling rather than data measurement. Data collection and during experiment calculation will affect the result of the experiment. Third, lack accuracy of data measurement due to load weight due to lack of preparation from the students. And lastly, tiny rope can be used during experiment to increase the data measurement accuracy. Okay, thank you.
Hi, I'm Kishan Gaunda. My matric number ID is CD190326, and I would like to present the results of this experiment. The results were collected by the left pivot bar and right pivot bar, and also totaled into M1 minus M2, and the ratios also have been deducted from the results that we obtained from the experiment. They are altogether 4 figures, and results were collected by the figures following by figure 3a, figure 3b, and figure 3c, and also figure 3d. Then when we look into the calculation of this experiment, the formula of moment, which is force into distance, have been used to obtain the moments. The formula has been used to obtain moments for figure 3a, 3b, 3c, and also 3d. And then moments were also calculated by the right pivot bar and also left pivot bar. The ratios also have been calculated by referring to the table that we have derived before, and also the distance are also collected from the table. So the calculation have been done using the formulas and also the results we have obtained from the experiment. Thank you.
Assalamualaikum. My name is Muhammad Faiz Afwan from Group 9 for subject Mechanical Engineering Laboratory. So the topic is the topic 4, Principle of Equilibrium. So in my part is question. So the first question is, what is the principle of moment and how moments achieve? So the answer is, principle of moment state that moments of force upon is product of the force and perpendicular distance of its line of action from the point moment achieved when the sum of clockwise is equal to the sum of anti-clockwise moment when the body is in equilibrium. If a body is in equilibrium under the action of a number of forces, then the algebraic sum of the moments of the forces about any point is equal to 0. Next, the second question is, what does the principle of moment state about the turning moments of forces acting on a body? So the answer for this question is, principle of moment state that if a body has several force applied to it which have turning effects in opposite direction, the body will not turn it if the total turning moment in each direction are equal. If the total anticlockwise moments do not equal to the total clockwise moment, there will be a resultant moment, so the body will turn. Then the last question is how to determine the moment in three-dimensional bodies. For this question, the answer is moment in three-dimensional body can be determined by using the mathematical approach called vector cross product. MO equals to R product F cross product of F, which R is the position vector from point O to any point on the line of action F. The calculation must consider a positive and negative signs since there are two directions of moment, clockwise and anti-clockwise. This vector cross product is used with a right-hand rule, which is a visualization technique used to determine the correct direction of a vector resultant from vector cross product multiplication. That's all for me. Thank you.
Hi, I'm Muhammad Amaluddin Mechanics from Group 9, and today I will explain about the discussion and conclusion about this experiment. From the graph obtained, F1 and F2 is directly proportional to d2 over d1 with a positive slope, even though the experiments were apparently affected by a few errors. This trend was expected as the book was set in equilibrium in each test. Since the system is in equilibrium, there is no resultant moment acting which would cause it to turn the weight hook about any point. And my second discussion is the summation of moment from the result must be 0 from all figures, figure A, 3A, 3B, 3C and 3D. Since the system was considered in equilibrium condition is each test configuration. When a body is in equilibrium, the sum of the anti-clockwise moment about any point is equal to the sum of the clockwise moment. In other words, the summation of moment is 0. And the factors that may influence the experiment is human error during measuring data gathering, and the testing device measurement is not accurate due to extensive usage. So the conclusion that we can conclude based on this experiment is that we understand the principle of moment in order to apply with real engineering design such as bridge, building structure, shipping construction and the others. The problem faced during this experiment are there are no small weight loads such as 0.05 Newton to balance the bar accurately, and a lot of friction occur in bar joint. The recommendation are handling carefully during run this experiment and do repeating data measurement in order to decrease parallax error and to get the accurate data.